Hello students. In this session, let us learn how aggregate blending will be done using rectangular chart method. We have already learned that aggregate blending will be done to obtain the required gradation with the help of blending two or more aggregates. So some of the methods involved in the aggregate blending involves the graphical methods, trial and error methods. The trial and error method was already discussed in the previous session, and now in this session we'll move on to the graphical method. Various graphical methods that are used to determine the aggregate blending involves the Rothfuss method, triangular chart method, and rectangular chart method. In this session we'll discuss on the rectangular chart or straight line method of aggregate blending. So similar to the trial and error method, before we move on to the aggregate blending procedure, it is required to obtain the gradation of individual aggregates. So now here we have two aggregates A and B, which has to be blended to obtain the required gradation. So table below here shows the percentage passing of aggregate A and B through the various sieve size, which includes 19, 12.5, 9.5, 4.575 mm, and so on. And they have also given the specific limits. So specific limits are nothing but the target values or the specification range when we to get the desired gradation. So now start with that. First, what you have to do is we need to plot all these things on a graph sheet. So we have to plot the gradation of aggregate A, gradation of aggregate B, as well as the specified limit on a graph sheet. To start with that, we have to consider a normal graph, a rectangle, to obtain the aggregate blending using the rectangular chart method. So now on the normal graph, you have to mark the values 0, 10, 20, 0 to 100 on y-axis. So here the y-axis value will represent the percentage passing of aggregate A and aggregate B respectively. Whereas x-axis represents the value on the x-axis represents the percentage of aggregate A in blend and a percentage of aggregate B in blend. So I mean to say that after blending procedure is done, so we will get, when we mix, what is the proportion of aggregate A and aggregate B need to be mixed to obtain the required gradation. Those value will be obtained on these two axes. Okay, so we'll take up step by step how the aggregate blending will be done using the rectangular chart method. So in the first step, what we have to do, we need to plot the gradation of aggregate A and aggregate B. So for that purpose, you can see here in this y axis, we have taken 0, 10, 20, 30, 40 up to 100 percentage passing of, first aggregate B is taken on this axis, and for percentage passing for aggregate A is taken in the other axis, 0 to 100%. Now the axis is ready for us to plot the percentage passing of each and every size of aggregate. So now what we have to do is, first we have to consider aggregate A. In the aggregate A, the first sieve is 19 mm and percentage passing for 19 mm sieve is 100%. So this point is marked on the graph. So how do you plot this? For aggregate A, this is the line which represents the percentage pass for aggregate A. So for aggregate A, the first value is 100% pass, which is through the 90 mm sieve. And similarly for aggregate B, percentage pass is 90 mm. So now what we have to do is join these 2 points, percentage passing for aggregate A and aggregate B. So this line will represent the 19 mm pass aggregate gradation for A and B aggregates. The next is we have to consider for the 12.5. 12.5 for aggregate A, the percentage passes, once again it is 100%. Whereas for aggregate B, the value is 92. So 92 will come here. And these 2 points has to be joined together to get the gradation line for 12.5 mm sieve. And next we need to move on for the next sieve size, that is 9.5. For 9.5 aggregate A it is 100%, whereas for aggregate B it is 54. So 54 value is somewhere here. Mark that and join these two lines. Similarly, so and we have to immediately write the sieve size for this particular line is 9.5 mm. And next move on to 4.5. 4.5 for aggregate A, percentage pass is 79%. 79% value is here. And for aggregate B, the percentage passing is 24. And join these two lines together to get the gradation line for 4.75 mm sieve. So similarly, for each and every sieve set, we need to plot a straight line in this method. Okay, so now we need to consider the values. For example, for 0.05 mm sieve, the specification range is between 8 to 6. The range here, the range is 8. Obtaining the gradation line for aggregate A and B, the next is we need to mark the specification limits. So how do you plot the specification limit? I'll first take the 0.05 mm because here the bottommost line what we are having is for number 200 or 0.075 mm. So now on this particular line we have to plot the specification range. How do you draw the specification range? So now for 0.75 mm sieve, the specification range is between 4 to 10%. Now this value has to be plotted here. Now how do you take, so now you have to in the same line, you have to check where we will have the 4% line. So now if you check here, the 4% value will come somewhere here. Okay, and similarly next value will be 10%. So the 10% value will come here. Okay, so now what we have to do is project this line and this will meet on the gradation line at some point, and similarly if you project 10%, that will meet at some point on number 200C. Similarly for the next percentage, this value has to be plotted on the next line, number 100 line. Okay, 16%. The first we have to check for where we'll get the 8. The value 8 will come at somewhere at this point, and the next value is 16 will come here. So what we have to do is we have to extend this line such that it will meet at the number 100 sieve line, and the same 16 also projected, and it will meet the number 100 line at some point. Similar to this, the specification limit for all the sieve range is plotted on respective lines. Once we obtain the specification limits, next step is we have to do the gradation. We have to find out how to combine the two aggregate A and B to obtain the required gradation. So now here we can see that these are the points which will represent the lower limit of the specification range, and on the other side that will represent the upper limit of the specification range. For example, if I consider 0.075, 4% is the lower limit value and the 10% will be upper limit value. For 0.0156, 8% is the lower limit value and 16% will be upper limit. So on to the leftmost side, we will obtain the lower limits of the specification limit, and to the right side, we will get the upper limit of the specification range. So the next step is we need to join each and every point of lower limit, and similarly that need to be joined on the upper limit side. And in the next step, we need to find out the innermost point at the lower limit and innermost point on the upper limit side. In the next step, we have to locate the innermost points on upper limit and the lower limit side. So if we check our graph here, the innermost point on lower limit side will be this, and innermost point on the upper limit side is this point. So in next, what we have to do is we have to draw a line passing through these points which are perpendicular to the x-axis. Now you can see here the first line here is passing through the innermost point of the lower limit side, and this particular line will represent the line passing through the innermost point of the upper limit side. So now the area between these two lines will gives you the desired gradation range. So now you can see here this particular line is meeting x-axis at 52% and this is meeting at the 62%. Similarly, on to the other side, the one line is meeting at 46% and other line is the at the 38%. Now we have already know that on this particular line it represents the percentage blend of aggregate A. So it's clearly say that aggregate A has to be mixed in the proportion range between 50 to 62% and aggregate B has to be taken in the range of 38 to 46%. This will be the range in which if you mix these two aggregates A and B, you will get the desired gradation. You can choose. So in the next stage, to obtain the what is the proportion of aggregate A and B required, you can choose any point which are in between these two range. Okay, for example, I can take one line which is exactly at the center. Okay, I can draw one line which is at the center. I'll get on this side it will get 57% and onto the other side I get 43%. So this indicates that if you mix aggregate A in the proportion 57% and aggregate B in the proportion 43%, we can achieve the required gradation. It need not to be the center point. Any value in between these two will gives you the design specification. For example, you can even choose aggregate A as 60%, aggregate B as 40%. That once again will be within these two range. Okay, you can choose any proportion within these range to obtain the required gradation. So now that can be checked here in this table. So at the midpoint, if you consider between these lines, proportion of aggregate A is 57% and for the aggregate B is 43%. So now what we have to do is, if you remember the trial and error method, to obtain the percentage in the blend, the percentage pass of all these material has to be multiplied with these two proportion. So for 57%, the fraction value becomes 0.57, and for aggregate B, the fraction value is decimal value becomes 0.43. So now all the values that are their percentage passing at these aggregate A and B has to be multiplied with 0.57 for aggregate A, and percentage passing of aggregate B will be multiplied with the 0.3. So that is tabulated here in this tabular column. You can see here. To obtain the percentage blend, percentage pass of aggregate A is multiplied with 0.57, and for B, the percentage pass is multiplied with 0.43. So now then you have to calculate the total blend. Total blend will be obtained by adding percentage blend of aggregate A and percentage blend of aggregate B. Okay, and next step and the final step, we need to compare the total blend what we have obtained with the specification limits. So now for 19 mm we have got 100%. The limit says we require 100%. It's fine. and for 12.5 obtained is 96.5. The limit is in between 80 to 100% and accepted. And for the next 9.5 mmc, what blend we have obtained is 80.2 and the range is in between 70 to 90, hence even this is accepted. And next is for 4.75, the range is between 50 to 70 and what we have obtained is 55 and we can accept. Like that, for all the C you can see the values what you have obtained, I mean to say that the total blend obtained is within the specification limit. So the blending what we have done is correct. So this is how we can apply rectangular chart or straight line method for aggregate blending. And one thing you have to remember here, using the rectangular chart or straight line method, it is possible for us to blend only two type of aggregates, aggregate A or aggregate 1 and 2 or aggregate A and B. If you are having more than two aggregate, we cannot use the triangular chart method or straight line method. For that purpose, we have a few more graphical methods that will be discussed in the upcoming classes. Thank you.